Okay, for today's lesson, we're going to start off with a little review. I do want to remind you that your first unit test, Unit 1, Test 1, will be Tuesday, August 29th. That is next Tuesday. So to help remind us of some things we've already done, our warm-up today covers operations with complex and simplifying imaginary numbers. So if you will hit pause, take a moment, and work these out. Then when you're ready to see the answers, press play. Okay, so let's talk about the first one. What we would do is we would think about how many times 4 goes into 37. We don't really care. What we care about, though, is the remainder. There's 1 left over. So I to the 37th is equivalent to I to the first power, which is just I. And this is what we would be looking for a correct answer on your test, Tuesday, August 29th. All right, number 2. We would distribute here, and when we do, we get 8i minus 12i squared. But remember, I squared has a value of -1. Remember our little saying? I won, I won, I won, I won. And the 2 in the middle are negative. So we know that I to the first is I. I squared is -1. I cubed is -I. And I to the 4th is 1. So when we have this as I squared, it's like multiplying by -1. And multiplying by -1 changes the sign. To receive full credit for this answer, though, you would have to write your answer in standard form for complex number. Remember, standard form is A plus BI form, where the real number part comes first and the imaginary part comes second. So this is the correct answer to number 2. Now, number 3. This is division, and with division, our rule is we cannot leave any imaginary parts in the denominator. Well, this denominator is not complex. It is just imaginary. Well, actually, imaginary does fall within the complex system, but it only has the imaginary part. So instead of multiplying by the conjugate, it is easiest to just multiply by -I. You want this to be a negative number times I squared, because this I squared is going to change that negative right back into a positive. So if this were negative to start with, you'd multiply by +I over +I. But since the denominator was positive to start with, we multiply by -I over -I. All right, and then we're going to have to distribute that numerator. When we do, the numerator becomes -3i minus 2i squared. That turns into a +2. So the numerator is 2 minus 3i. And so what I'd be looking for correct answer on your test would be 2 minus 3i over 4. Now, we also said another acceptable answer would be where we split it, 1/2 minus 3i over 4, because that 2/4 simply simplifies to 1/2. All right, if you have any questions about this warm-up, you can ask me if you're in class the morning session. I am not here, so you can save those questions for Friday. If you're in the afternoon, I should be back. Okay, let's take a look at your homework. Now, I will be looking for not only completed homework when I check homework Friday, but corrected homework. So make sure you have those red pens out. If you don't, press pause. Go grab a red pen so you can make your corrections. Number 1, we're going to take out the GCF. And when we do, we're left with this. Okay, the reason we're doing this is because we need it in factored form. We need our equations in factored form so that we can find our x-intercepts. When we factor this completely, it factors to this equation, y equals x times x plus 4 times x minus 2. Now we're looking at 2 things here. 1, we're looking at the factors. 2, we're looking at the degrees. The factors tell us the roots. The roots of this equation occur where x equals 0 here, -4 here, and +2 here, because these are the values that I could substitute in for x that would make this equivalent to 0. Now, that means when I come up here to my x-axis, I will put an intercept at -4 an intercept at 0, 0, and another one at 2, 0. So that is step 1 to graphing. Factor, find your x-intercepts. So plot those intercepts. Step 2, the x-intercepts. Step 2 is to deal with the end behavior. There's 2 places we can look for the degree of this function. We can look here, we see it's 3, or we can look here, 1, 2, 3. Either way, the degree of this function is 3, and it has a positive leading coefficient. So a positive leading coefficient and an odd degree tells me it's going to fall to the left and rise to the right. Each of the factors is just to the understood first power. There is no multiplicity at the root. It's going to pass straight through, pass straight through, pass straight through, no inflection. And that is number 1. Number 2, we factor out the x. We're left with x squared minus 9. The x squared minus 9 factors again to x plus 3 times x minus 3. This is our factored form. The factored form does give us the roots. And so we know the roots of this equation would be 0, negative 3, and positive 3. We plot those as our x-intercepts. We look at the degree of the function now to come up with the end behavior. It's an odd degree function with a positive leading coefficient. It's going to fall to the left and rise to the right. Each of these factors into the first power, so there's no multiplicity at the root. We're just going straight through. All right, let's take a look at number 3. Number 3 is already factored for us. How nice. Its factors are just x minus 4. That factor is cubed, though. So that tells me something different is happening right here at this x-intercept of positive 4. Not only is it going to pass because this factor is odd, because there's multiplicity, odd multiplicity, when it passes through this x-intercept, it will pass with an inflection. Now, if we look at that leading coefficient for this odd degree function, it is negative, which tells me it's going to rise to the left and fall to the right. Now, did you see how I put the kind of squiggle in the graph? The squiggle in the graph really indicates that this graph is going from concave up to concave down. In mathematics, we call this point an inflection point. Okay, this one. This has a GCF, so let's factor that GCF of 3x out of this equation first. When we do, it leaves me with 2x squared minus x minus 15. Now this 2x squared minus x minus 15 will factor further. It factors to 2x plus 5 and x minus 3. So these are our factors here. And that's how we would write this. 2x plus 5 and x minus 3. All right, so my roots are, 2 of them are easy to see. 0 and the 3. Now, this factor here, if you need to set it equal to 0 and solve it in order to see what x is, do it. If you can do it in your head, do it in your head. This one turns out to be negative 5 halves. Negative 5 halves is the same as negative 2.5 if you have that. Okay, now we're going to plot those x-intercepts. So we have one at positive 3, one at 0, and one at negative 2.5, or negative 5 halves. Odd degree function, positive leading coefficient, falls to the left, rises to the right. Each of the factors is to the first power. There's no multiplicity, so we're passing straight through, no change in concavity at any of those points, no inflection points. All right, let's take a look at the last 2. Oh, this one's a fun one. It is a quartic that's in quadratic form. So we can factor it like this, x squared minus 4 and x squared minus 1. Now, each of these factors further. This factors to x plus 2 times x minus 2. This factors to x plus 1 times x minus 1. And so those are our factors. So y equals x plus 2, x minus 2, x plus 1, x minus 1, which gives me roots of negative 2, positive 2, negative 1, positive 1. this is a even degree function. So when I come in here and I plot all those, I know that the ends, because it's even with a positive leading coefficient, will rise, and we will pass. First. Pass through. All right, and finally this one. It's already factored, so this is what goes there. We have roots at 0. This gives me the 0. At -4 and at +4. So 1, 2, 3, 4, we need an x-intercept. 1, 2, 3, 4, we need an x-intercept. Let's count the degree. 2, 3, 4. It's an even degree function. It's a 4th degree, even degree. Negative leading coefficient falls to the left, falls to the right. Okay, it's going to pass through the -4 because it's to the first power. It's going to bounce. And the math word we use for that, if we're describing that, would be tangent. It is tangent at 0 because x is being squared. And it passes through at +4. And that's what our graph would look like. Okay, let's flip to the back of that second page now. And we're going to do a couple of these together. And then your assignment is to finish the rest on your own. All right. The directions say to list the roots of the following graphs and the equation. Describe the root behavior, okay? So we're looking for tangent, passes through, or passes with a point of inflection. And then we're going to give the exponent for each of the factors and then write the equation. So let's take a look at this. Words can be confusing sometimes. Math is never. All right, if we look at this, it's counting by 2's. So this point right here, this x-intercept is -3. So that is one of our roots, -3. So at -3, it is bouncing, which means it is tangent at that root. It is tangent at x equals -3. Now, what would my factor look like? It would be x plus 3. Remember, it's always the opposite in here. And because it's tangent, that tells me there is even multiplicity. Because it bounces, this is a 2. All right, next one. It is 0 right here, x equals 0. And at x equals 0, it passes. So my factor would just be x. I could write x minus 0, but x is much simpler. And then my last one right here is +2. X equals +2, and it's just passing straight through. There is no reflection. So this would be x minus 2 to the first power. Now with the first power, we don't need to write it. Now when we go to write our equation, we should start with any monomials, so the plain old x's would come first, and then the order of your binomials really doesn't matter. And there's the equation for that graph. Okay, you can pause, take a minute, write that down if you need to, rewind if you need to. Let's look at number 2. We have these intercepts. So we have roots at -2, at -1, and at +2. Now we need to decide what's happening at each root. At -2, it passes. At -1, it bounces. Therefore, we would call it tangent. And at +2, it doesn't just pass. Look at the concavity. Concave down to concave up. It passes with inflection. There's an inflection point there. Okay, so what does that tell me about the factors and the exponents for those factors? The first factor would be x plus 2. If this is -2, this is +2. It's passing, so it's first degree. The second one would be x plus 1. It is tangent, so it would at least have to be a second degree. And this one is x minus 2. Because it passes with inflection, it has to be at least a third power here. And so when we do them of least degree, we're going like this. Now, the last thing that I failed to mention on the first one is we have to look at the end behavior to decide if we need to throw a negative in here. But because this rises and rises, and this is our 6th degree, and we currently have a positive leading coefficient, we don't have to worry about it. Same here. This was a 4th degree. It has a positive leading coefficient, so that does give us the rise. Okay, this one. Now what? Ignore that bell. If we look at this one, we have roots at -4, at 0, and at 2. Okay? And so they're passing with each one of them. And so this would give me x plus 4. This gives me x. This gives me x minus 2. So my equation would be this. X plus 4, x minus 2. But we check out the end behavior. It's rising to the left and falling to the right, so we need the negative. This negative causes this end behavior to occur with an odd degree function, 1, 2, 3. All right, so your assignment is to finish the rest of this packet. And I will check everything tomorrow. Check corrections on your homework and check completion of this packet. Good luck. If you have any questions, just mark it and I will answer all of them the next time I see you.